C320. Outline: pavement purpose, pavement significance, pavement condition, pavement types, flexible rigid pavement design. Example: pavement purpose, load support, smoothness, drainage. DC to Richmond Road in 1919, from the Asphalt Institute. Pavement significance: how much pavement? 3.97 million centerline miles in US. 2.5 million miles, 63%, are paved. 8.30 million lane miles total. Largest single use of HMA and PCC. Costs $20 to $30 billion spent annually on pavements. Over $100 million spent annually in war. Pavement condition. Pavement condition. Pavement condition. Pavement condition. Pavement condition. Defined by users, drivers, developer methods to relate physical attributes to driver ratings. Result is usually a numerical scale, from the Asher Road Test, 1956 to 1961. Present Serviceability Rating, PSR, picture from Highway Research Board Special Report 61 AG. Present Serviceability Index, PSI, values from 0 through 5 calculated value to match PSR. SV equals mean of the slope variance in the two wheelpaths, measured with the Chloe profilometer or BPR barometer. C. P equals measures of cracking and patching in the pavement surface. C equals total linear feet of Class 3 and Class 4 cracks per 1000 ft2 of pavement area. A Class 3 crack is defined as opened or spalled, at the surface, to a width of 0.25 inches or more over a distance equal to at least 1/2 the crack length. A Class 4 is defined as any crack which has been sealed. P equals expressed in terms of ft2 per 1000 ft2 of pavement surfacing. F. Typical PSI versus time. Time, serviceability, PSI, P0, PT, P0, PT. Design parameters, subgrade loads, environment. Subgrade, characterized by strength and/or stiffness. California Bearing Ratio, CBR, measures shearing resistance units, percent typical values, 0 to 20. Resilient modulus, MR, measures stress-strain relationship units, psi or MPa. Typical values, 3,000 to 40,000 pounds per square inch. Picture from University of Tokyo Geotechnical Subgrade. Some typical values. Loads. Load characterization. Tire loads. Axle and tire configurations. Load repetition. Traffic distribution. Vehicle speed. Load quantification. Equivalence. Single axle load. A SL converts wheel loads of various magnitudes and repetitions, mixed traffic, to an equivalent number of standard or equivalent loads based on the amount of damage they do to the pavement. Commonly used standard load is the 18,000 pounds equivalence single axle load. Load equivalency. Generalized fourth power approximation. Typical lefts. Notice that cars are insignificant and thus usually ignored in pavement design. Left example. The standard axle weights for a standing room only loaded metro articulated bus, 60 feet flyer, R. Axle empty full steering £13,000 £17,000 middle £15,000 £20,000 rear £9,000 £14,000. Using the fourth power approximation, determine the total equivalent damage caused by this bus in terms of ISLs when it is empty. How about when it is full? Environment. Temperature extremes. Frost action. Frost heave or weakening. Pavement types. Flexible pavement. Hot mix asphalt, HMA. Pavements called flexible since the total pavement structure bends, or flexes, to accommodate traffic loads. About 82.2% of paved U.S. roads use flexible pavement. About 95.7% of paved U.S. roads are surfaced with HMA.